Today we're talking about the last major strategy for solving systems of two equations with two unknowns, linear equations anyway, which is elimination. And elimination is actually really important, especially if you think you're going to go fairly far in math, because it's really setting yourself up to be able to tackle matrices in the future. And the idea of elimination is that you end up combining equations by adding or subtracting the whole equation from each other in order to eliminate one variable. And let's take a look at what that means. So first things first is you want to align your equations straight on top of each other, just like we have here, so that all of the x's are straight on top of each other, all the y's are straight on top of each other, equals all of the constants straight on top of each other. And if for whatever reason one of the equations is missing a variable, just kind of leave that as like a blank open space or write down 0 of that variable there. Because you want to make it crystal clear what goes where in your equations, kind of like lining up your place values. Then you want to make sure that your equations are such that one of the variables is going to eliminate when you add straight down. Now in this particular equation, those are already set up that way. But let's say if instead of the second equation you had negative x minus 9y is equal to negative 5 written, then what you would have done with that equation is multiplied it by 2. 2 times negative x giving you negative 2x, 2 times negative 9y giving you negative 18y, and then 2 times negative 5 giving you negative 10 in order to create the second equation. How would you have known to multiply by 2? Well, you would have wanted this to happen with your x's, such that when you add the equation straight down, 2 plus negative 2x is going to then eliminate to make 0 x's. You'll know that you set up your equations right if that happens. Then you continue to add straight down. Negative 6y plus negative 18y is going to give us negative 24y equals negative 14 plus negative 10 is going to give us negative 24. Now we just have one more step in order to get y by itself, where you will divide by negative 24, negative 24. Negative 24 divided by 24 is just 1. And then you're going to substitute that value back into one of your two equations to find the remaining variable. So in this case, I'm going to pick the first one. So we'd have 2x minus 6 times y is equal to negative 14. And what is y equal to? It is equal to 1. So I'm going to go ahead and replace everywhere I see a y with a 1. Then we'd be left with 2x minus 6 is equal to negative 14. We want to get x by itself, so we're going to undo subtracting 6 by adding 6 on both sides. I end up with 2x is equal to negative 8. And then as a final step, you will divide both sides by 2 to get that x is equal to negative 4. So you would have just confirmed that your full coordinate that's a solution is negative 4, comma 1. And you're encouraged to go ahead and also plug that into your other equation just to make sure that it does indeed work, which in this case, if you did, you would get what? 8 minus 18, which does indeed get you negative 10, so you're good. Those are the kind of basic scenarios, and just like last time, it's a no solution situation if you find all the variables eliminate and you're left with some nonsense like 7 equals 0. Versus if it's infinite solutions if you have all the variables eliminate and you're left with something that makes sense, such as 0 equals 0. So let's take a look at an example that's just a little bit trickier, because this time, if I were to add straight down, nothing's going to eliminate. What do I mean by that? If I add straight down, I would get what? Negative 3x minus 8y is equal to 31. That doesn't help me. Nothing has eliminated. So instead, I've got to multiply one of these two equations by something, and sometimes even both equations by something, so that something eliminates. What I notice in particular is if I multiply the first equation by 4, because 4 times x gives me 4x, and 4x plus negative 4x is going to eliminate to make 0, that's what I think I want to multiply that first equation by. If I do that, I would do 4 times x to get me 4x. 4 times negative 12y to get us negative 48y. And then 4 times 63, I'm going to have to do that off to the side personally. 4 times 3 is 12, carry the 1. 6 times 4 is 24, plus 1 gets us 25, equals 252. And then the other equation, I'm just going to rewrite exactly as is. Now you might be wondering, why didn't you just multiply the second equation by 3 to eliminate y? You could have done that too. Tomato, tomato, they're both going to work. Now we're ready to go ahead and just add straight down. 4x minus 4x is going to make 0, just like I wanted. Negative 48y plus 4y is going to make 44y. 252 minus 32 is going to get me 220. Now I need to get y by itself, so I'm going to divide by 44. And oh, I actually made a sign error because a negative plus a positive is a negative. So I'm really dividing by negative 44. Negative 48y plus a positive 4y will be a negative 44y. Negative 44 divided by negative 44 is going to make 1. And then this division, I'm going to personally just kind of simplify by dividing by 2 at a time until I can't anymore, because I know that 2 has got to go into both of those. Negative 44 divided by 2 is negative 22. 220 divided by 2 is going to give me 110. Then I'm going to divide both by 11, because I noticed that 11 definitely goes into both. That will give me 10 over negative 2, and then 10 divided by negative 2 gives me negative 5. So I just slowly but surely did that division, sort of just slowly simplify that fraction sort of strategy. So I've just confirmed that the y-coordinate is definitely negative 5, and now I'm going to go ahead and substitute that back into one of my originals in order to find x. So I have x minus 12 times negative 5 is going to give me 63. Negative 12 times negative 5 is going to get me positive 60, equaling 63. And then my last step to get x by itself will be to subtract 60 from both sides, so I get x is equal to 3. And this is a case where I can also show you the way that you would check your work is by just plugging into the other equations. So we have negative 4 times 3 plus 4 times negative 5 should equal negative 32 if we did this right. Negative 4 times 3 is negative 12. Negative 4 times 5 is negative 20. And negative 32 does indeed equal negative 32, so I know I did this correctly because it works in both equations. Go ahead and pause your video and see if you can do these next two yourself. My hint for number 2 is you're probably going to want to multiply both equations by something in order to make sure something eliminates. Okay, so if you're trying to figure out what am I going to multiply this equation by in order to make sure something eliminates, a worst case scenario strategy is you can always multiply them by each other, but if I'm thinking a little bit strategically, then I would be thinking that the least common multiple of 8 and 12 would be 24. So I'm thinking maybe if I multiply the first equation by 3 and the second equation by negative 2, then I'm going to end up with that first coefficient on the x being a positive 24 in one equation and a negative 24 in the other equation, and I'll be good to go in order to solve. So if I multiply the first equation by 3, 3 times negative 8x gets me negative 24x. 3 times positive 8y is going to get me, I'm blanking. 3 times 8 is 24 as well. Yeah, that's why I just did that. And then 3 times 24 is going to be 72. Then we want to keep on going. Negative 2 times negative 12x is going to get me positive 24x. Negative 2 times positive 12y is going to get me negative 24y. Negative 2 times positive 40 is going to get me negative 80. Then when we add straight down, this is when one of the special case scenarios happen, because negative 24x plus 24x eliminates to make 0. Positive 24y minus 24y eliminates to make 0. So I'm left with 0 is equal to positive 72 minus 80 is going to give me negative 8. And this is a false statement because the last time I checked, 0 does not equal negative 8. So this is no solution. These would be considered inconsistent. And if you were to solve these out for y for both of these equations, you should find that they have the same slope but different intercepts. So that means that they are two parallel lines who never touch. For this next one, it looks like we're going to have to be in a similar sort of scenario where we're going to have to multiply both equations. Unless we felt comfortable multiplying by a fraction, which you can also technically do, but I choose to just multiply both equations. So in particular, let's maybe eliminate y this time. So for the y's, 5y and 3y, I'm thinking their least common multiple is going to be 15. So I'm going to multiply the first equation by 5 so that becomes a negative 15y, and the second equation by 3 so that becomes a positive 15y, and that way my y's can eliminate. For the first equation, when I do 5 times negative 5x, that gets me negative 25x. 5 times negative 3y is going to give me negative 15y. 5 times a positive 25 is going to get me 125. Then I want to keep on going. 3 times negative 2x is going to get me negative 6x. 3 times positive 5y will give me positive 15y. 3 times negative 21 is going to get me negative 63. Now I'm ready to add straight down. Negative 25x plus negative 6x is going to get me negative 31x. Negative 15y plus 15y will eliminate to make 0, just like I wanted. And 25 minus 63, 5 minus 3 is 2, 12 minus 6 is 6. That gives me positive 62. As a final step, I need to divide both sides by negative 31 in order to get x by itself. So I'm going to get x is negative 2. I haven't finished yet. I've only found my x coordinate. Now I need to plug that into one of my equations to find the y coordinate. I'm just going to pick the second equation. So if I'm plugging into the second equation, that becomes negative 2 times negative 2 plus 5y is equal to negative 21. If I keep on solving, negative 2 times negative 2 is 4, plus 5y is equal to negative 21. Then I want to go ahead and subtract 4 from both sides. 5y is equal to negative 25. Then I want to undo multiplying by 5 by dividing by 5 on both sides. So then I get y is equal to negative 5, and negative 5 is my second coordinate. And I would encourage you to go ahead and practice re-plugging that into the first equation, because you should find that that solution does indeed work for that equation. Which, if I'm just going to kind of quickly do in my head here, negative 5 times negative 2 is positive 10. Negative 5 times negative 3 is positive 15, and positive 10 plus positive 15 does give us 25. So we are good. It does work in the first equation. Last but not least, let's go ahead and do this next set of equations. So I would go ahead and encourage you to pause your video, try this yourself, and then we'll compare answers. So for this one, it actually looks like I only need to multiply the first equation, because if I multiply the first equation by 2, then my x's are going to eliminate, because if I do 2 times negative 5x, that gets me negative 10x. 2 times negative 3y gets me negative 6y. 2 times positive 2 gets me 4. And then when I add these two equations straight down, then I'm in a special case scenario, because 10x minus 10x, that makes 0. 6y minus 6y, that makes 0. Negative 4 plus 4, that also makes 0. So I'm left with 0 equals 0. That means that we're in a situation where there are infinitely, how do you spell? That's always a great question. Infinitely many solutions. Pretty sure I just spelled infinitely wrong still, but I don't care at this point. You know what I mean. Infinitely many solutions. That means they are consistent but dependent. Both of these are just rearrangements of the exact same equation. So in particular, if I insisted on finding the equation, I'm just going to pick to solve with the first equation. If I were to solve for y and not mix up writing my x's as y's, I would first add 5x to both sides to undo adding negative 5x. Negative 3y equals positive 5x plus 2. Then as my next step, I would divide all three terms by negative 3 in order to get y by itself. So both of these are the equation. Y equals negative 5/3 x plus negative 2/3, rearranged in some way. So it has a slope of negative 5/3 and a y-intercept of negative 2/3. And you kind of know that things are well set up for elimination in this way. If it's not that easy to get a variable by itself, and in particular if getting a variable by itself is going to be a whole bunch of messy fractions like this last one, it's probably just going to be easier to do elimination instead. It's not technically wrong to do substitution instead of elimination, or vice versa. Both of them are completely valid algebraic things in order to solve for equations, but you want to be comfortable with both because there's certain situations when one will be easier than the other.